Hello! In this video, we are going to prove the following theorem. Let I be an interval, f be a function from I to r, g be a function from I to r, and c is an element of I. And suppose f and g are differentiable at c. Then f plus g is differentiable at c, and the derivative of f plus g at c is equal to the derivative of f at c plus the derivative of g at c. Now, to prove this theorem, the approach we are going to be using is by using Carathéodory's theorem for derivatives, which says the following. Let I be an interval, let f be a function from I to r, and let c be an element of I. Then f is differentiable at c, if and only if there exists a function phi from I to r that is continuous at c, and it has the property that f of x minus f of c is equal to phi of x times x minus c for all x and I. In this case, the derivative of f at c is equal to phi evaluated at c. Okay, so now let's get into proving this theorem. To start out the proof, since f is differentiable at c, according to Carathéodory's theorem, there exists a function phi from I to r that is continuous at c, and we have f of x minus f of c equal to phi of x times x minus c for all x and I. In addition, the derivative of f at c is phi of c. Similarly, since g is differentiable at c, we apply Carathéodory's theorem again. It follows that there exists a function I will call psi from I to r that is continuous at c, and it has the property that g of x minus g of c is equal to psi of x times x minus c for all x and I. And in this case, the derivative of g at c is equal to psi of c. Now the whole goal is to show that f plus g is differentiable at c, and that the derivative of f plus g at c is this value. And to do that, we are going to apply Carathéodory's theorem. So, in Carathéodory's theorem, we are taking this function to be f plus g, right? To show that f plus g is differentiable at c, we want to show that there exists a function from I to r that is continuous at c, and f plus g of x minus f plus g of c is equal to that function evaluated at x times x minus c for all x and I. Now, it's almost natural to take this function to be the function phi plus psi. And so that's the function that's going to work. So we're going to take this function to be phi plus psi. All right, certainly, since phi is a function from I to r and psi is a function from I to r, the sum of those two functions, phi plus psi, is a function from I to r, right? Furthermore, it satisfies the continuity condition. Since phi is continuous at c and psi is continuous at c, it follows that the sum of the two functions, phi plus psi, is continuous at c, right? That's just the addition rule for continuity. Right, so for phi plus psi, the continuity condition is satisfied. But now we want to verify that this equality is true for all x and I. So to do that, let's give ourselves an arbitrary x and I. And now let's write the left-hand side. So we have f plus g of x minus f plus g of c is equal to what? We should show that this is equal to phi plus psi of x times x minus c. And so to see that, well, we know that f plus g of x is just f of x plus g of x. And we're subtracting that by f plus g of c, which is just f of c plus g of c. And now regrouping this stuff, we have f of x minus f of c plus g of x minus g of c. But then we go to this equality and this equality. We see that f of x minus f of c is equal to phi of x times x minus c. G of x minus g of c is equal to psi of x times x minus c. And then we factor out the x minus c. But then phi of x plus psi of x is precisely phi plus psi evaluated at x. And that's multiplied by x minus c. And so, through this chain of equalities, we have established f plus g of x minus f plus g of c is equal to phi plus psi of x times x minus c, right? For an arbitrary x and I, right? X is arbitrary. So we have established this condition as well. And so we have shown that there exists a function from I to R, continuous at C, that satisfies this condition. So according to Carathéodory's theorem, that tells us f plus g is differentiable at C. And in fact, the derivative of f plus g at C is phi plus psi evaluated at C. Now, phi plus psi evaluated at C is phi of C plus psi of C. But we know phi of C is equal to f prime of C, and psi of C is equal to g prime of C. So we have f prime of C plus g prime of C. And so we see that f plus g prime of C is equal to f prime of C plus g prime of C. And that's what we wanted to show. So this completes the proof. And so yeah, that's pretty much it for this video.